Alright guys, so I had a question about how to answer questions 7 and 8 on the whole first homework and web assign. Alright, so this is number 7. Now remember everybody's question is going to be slightly different. So here's my number 7. It's going to be slightly different than your number 7. And here's my number 8. Will be slightly different than your number 8. Let's look at number 7. Okay, so we have this function. Consider the function f of x equals 6x plus x squared and the point P, -2, -8. Okay? So first step here, part A, is to figure out which graph even works. Okay, well, by process of elimination, we should probably be able to figure out which one of these is correct. Now, that's using the rules of algebra. Now, let's think about this. We should be able to eliminate 2 right off the bat. Okay? 2 right off the bat because this right here, x squared, has a coefficient of +1. Now remember, if you have a quadratic function and the coefficient of your quadratic term is positive, that means it is a parabola where it is opening upwards. Okay? If the coefficient of your quadratic term is negative, that means your parabola will be opening downwards. So these 2 right here are opening downwards. So they would have an equation where the quadratic term is negative. Here we have a quadratic term is positive. So these 2 are ruled out right off the bat. Now, to use the ideas from algebra to figure out which one of these is correct, we would need to get this in standard form. Okay, that's in general form. Well, it's not exactly in general form. It's approximately general form right now. To get it in standard form, you would need to complete the square. Completing the square would allow us to get it in standard form and then figure out, okay, is it a parabola that's been translated down into the left or down to the right? Okay? That's going to take a few minutes. Here's a better idea. Just use a graphing calculator. We're going to use a graphing calculator a ton. That's not considered cheating or anything. It's just considered being efficient. So I have a calculator pulled up here. Here's a really good one online. Okay, it's called Desmos. Okay, just right here, desmos.com. Now let's see here. What was our graph? If I remember correctly, it was f of x. Now we can use y here. Y equals, I think it was 6x plus x. Oh, not there. X squared. Okay, let's zoom out a little bit. So there is our graph. Desmos is a really great online graphing calculator. I wouldn't recommend necessarily using it all the time because you need to make yourself very familiar with the calculator you'll be using for tests. But I'm going to use it here because it makes really nice pictures. Okay, let's see. Yeah, let's get it like right there. Okay, now let's see what the assignment asked us to do here. Okay, so I have this function and the point -2, -8. So let's go ahead and graph -2, -8. Oh, that's the wrong one. Let's minimize that. All right, -2, -8. All right, so there is the point in question. We want to eventually find the tangent line through that point. All right, well, we don't have the tools of calculus yet, so we're going to use the tools of algebra to approximate, and actually we're going to find the slope of that tangent line by using secant lines. Okay, now remember, what is a secant line? A secant line is a line that passes through 2 points on a curve. Okay, I'm going to turn that off so we can see better. Alright, so what's nice about Desmos is that it color codes everything. So we have a red parabola here, we have a blue point. Okay, so let's go back to the instructions. So we want to graph the secant line that passes through -2, -8, and then the corresponding points when we have these x values. Now notice they don't give us other ordered pairs. They give us other x values. So we need to find first, okay, when x is -3, what is y? When x is -2.5, what is y? When x is -1.5, what's the corresponding y value? what's the corresponding f of x value. Okay, now to do that, use your function. Okay, let's think about this. Okay, if x is negative 3, then what's y going to be? What's f of x going to be? Well, 6 times negative 3 is negative 18 plus negative 3 squared. Negative 3 squared is positive 9. So we have negative 18 plus positive 9 is negative 9. So we have the point negative 3, negative 9 on our graph. So negative 3, comma, negative 9. Now, so that's the first point. We want to find a secant line in conjunction with the original point. Okay, so we want to find the equation of the line. Well, we don't have to find the equation. Well, I am. What you want to do for your homework is find the slope of this line that passes through these 2 points. The secant line that passes through the green dot and the blue dot. Well, to find a secant line, to find the equation of that line, what's the first thing you need? The first thing you need is slope. Okay, well, we know how to find the slope of a line between 2 points. So we need to use our slope formula with these 2 points, with the blue point and the green point. Okay, so label your points, x1, y1, x2, y2, use the slope formula, and I think when you do that, you're going to find the slope of the line, in fact the secant line, between these 2 points. The slope is going to be 1. Okay, now that's all you need for WebAssign, for your homework, but I'm going to go ahead and graph the lines. So how would you graph find the equation of the line that passes through those 2 points that we already know has a slope of 1? Well, that's easy. Remember, use point slope form. Point slope form is y minus, oh, I can't type a subscript here, can I? Okay, well, it's y minus y1, oh yeah, I can, equals m times x minus x1. Okay, that is your point slope form. Now remember, x1 and y1, those are given by a point on your graph. So I'm going to use negative 2 and negative 8 for x1 and y1 respectively, and my slope that I found was 1. So it's going to be y minus y1. Well, y1 is negative 8. Okay, so it's going to be y minus negative 8. So it's going to be y plus 8 equals m, which is 1, times x minus x1. Well, x1 is negative 2, so minus negative 2 would be plus 2. So there is that secant line. So the purple line is the secant line that passes through these 2 points right here. Okay. Now, the next point on the graph, at least in my example, was negative 2.5. Or excuse me, the next x value. So when x, now remember this is our function right here, when x is negative 2.5, let's figure out what y is. Well, it turns out that when x equals negative 2.5, that y equals negative 8.75. So there's the next point we're working with, this orange point. Okay, so now we want to find the secant line of the line, excuse me, the secant line that passes through this orange point and the blue point. So we need to find the slope of now this orange point and the blue point. Okay, so if you employ the slope formula, it turns out the slope of that secant line is 1.5. Now, that's what you need for WebAssign, for your homework. They don't ask you for the equation of the line, but to find the equation of the line, you'd use point slope form. And again, the x1 and y1 are going to be negative 2 and negative 8 respectively, so the equation of that line is going to be y plus 8 equals m, which we just figured out was 1.5, times x minus, well, not minus, it's going to be minus negative, so plus 2. So there is the secant line that passes through the orange and blue dots. Blue dot, okay? So this black line is now a better approximation for our tangent line. So the purple line was an okay approximation. The black line is a better approximation. Now let's pick a point even closer to this point, which is -2, -8. Okay, so we went from -3. So imagine on our x-axis, our point in question is -2, -8. So on an x-axis, we started at -3, and let's move closer and closer from the left, moving to the right, from -3 to -2. So we went to -2.5. Let's go -2.25. So -2.25, comma, okay, what's f of -2.25? That would be 6 times -2.25 plus -2.25 squared. That ends up being -8.4375. Okay, so this red dot now, or kind of maroonish red, we want to find the secant line that passes through it and our original blue dot, the original point in question. Now, again, we're going to employ the slope formula. Okay, so we're going to find the slope of this point right here, or the line that passes through this point right here, the red, and the blue. Okay, yeah, again, it's decimals, but you can use the slope formula, no big deal. Turns out that slope is 1.75, which means we can write the equation of the secant line as y plus 8 equals slope, which is 1.75, times x minus x1, which is x minus -2, which is x plus 2. So now we have this blue line here, this navy bluish line. That's even a better approximation of the tangent line of the curve at -2, -8. Okay? Well, now let's pick an x value even closer to -2. Again, we're moving from -3 on the left, closer and closer and closer to -2. These are x values we're talking about. So, let's half the distance between -2.25 and -2. Well, that would give us an x value of -2.125, right? That's halving the distance between -2.25 and -2. Okay, so what is? Oh, I should put some parentheses here. Okay, so what is the f of x when x equals -2.125? Well, just plug it into your original function, and it looks like it is -8.23475. So now I've repeated colors. Oh well, the color coding is not the best. But now I have another green dot, and notice how it's getting closer and closer to my original blue dot, the point in question, where I want to know the tangent line. Okay, so now I want to find the secant line between this new green dot and my original blue dot. Again, employ the slope formula. So I want to find the slope with these coordinates and with these coordinates. Again, I mean, it's got some decimals there, but it's not hard to use the slope formula. It turns out the slope of that new secant line is going to be 1.878. Okay, so that would mean the new secant line equation is y plus 8 equals m, which I just said was 1.878 times x minus x1, which is x plus 2. And now, see this darker purple line. This darker purple line is the new secant line. Okay. So see here, as we get closer and closer and closer and closer to this blue point here, the secant lines appear to be better and better approximations of a tangent line. Now remember, what's a tangent line? A tangent line is a line that intersects a curve at exactly one point. Okay? And that's what we're going for here. So if I keep picking, let's see if I can zoom in here. If I keep picking points that are closer and closer to this blue point here, I'll get better and better approximations of my tangent line. Now, what do you notice here about the slopes? Okay, the slope, our first slope we found was 1, right here. Our second slope we found was 1.5, right here. Our third slope we found was 1.75, right here. Now our fourth point was 1.878, right here. So obviously the slopes are increasing. Now the question is, are they approaching any specific number? Well, let's see. Let's pick a point really close to our original point in question, which was -2, -8. Let's pick the point -2.001. That's really close to -2 on the left of -2. Now, what's f of that value? Well, I don't know. Let's see here. 6 times -2.001 plus -2.001 squared. I get -8.001999. Okay? So now I want to find the slope of the secant line that passes through this point right here, which is super close to my original point. In fact, it covers it up on the graph because it's so close. I want to find the slope of the line, the secant line, between this point right here, this orange, my new orange, and my original blue point. So I'm going to use the slope formula with this point right here and this point right here. Now I'm going to do, I haven't done that yet. Let me do it real fast. Let's see here. I'm just using my calculator real fast, and syntax there, that's no good. -2, -8. Then I said -2.001 and -8.001999. Okay, I get my slope to be 1.999. Okay, so if my new slope is 1.999, the new secant line is going to be, let's see, how to write the equation line again. It was y plus 8 equals m, which is 1.999 times x minus x1, which was that simplified to x plus 2. So which line did I get? A new black line, a new darker black line. So see again how my secant lines are getting to be better and better approximations of my tangent line at the point -2, -8. Now, what do you think is going on here with the slopes? We went from 1 to 1.5 to 1.75 to 1.878 to 1.999. Can you guess what point we're approaching here? Let's pick one more. Let's do one more. Okay? Let's pick the point that's even closer on the left to -2. Let's pick the point -2.0001. So that's even closer. Comma. Okay, what's f of -2.0001? Well, let's see. That's 6 times -2.0001 plus -2.0001 squared. And the f of x value is -8.00019999. Okay? Alright, see how we're getting closer and closer to -2, -8. So now, okay, so this is a point I've picked even closer to -2, -8. Let's find the slope of the secant line between this point right here and my original point of -2, -8. So let me do that real fast. Let me use my calculator, and I'm going to get, let's see, and I get 1.8 9999 this time. Okay, so if my new slope is 1.9999, then the equation of that new secant line is going to be y plus 8, plus 8 equals 1.9999 times x minus x1, which is x plus 2. So I hope now we can maybe see, okay, graphically we're getting better and better approximations of our tangent line, and I hope we can see by examining the progression of the slopes what number the slope is approaching. 1.5. Actually, we started off 1, 1.5, 1.75, 1.878, 1.999, 1.9999. Got a guess? It looks like 2 to me. Okay? I think we can safely assume that the slope of the tangent line is going to be 2. Let me see if I can hide all these. Yeah. Okay? I'm going to hide these in progression. Okay, so there's my original. I'm going to leave that. Okay, let's hide our original, the first secant line. That's gone. Hide the second secant line. Okay, that's gone. Hide the third secant line. Okay, that's gone. Hide the fourth one. Hide the fifth one. And there is our sixth tangent line. See here the progression of points? The points were getting closer and closer and closer to our point in question, when in fact the last point I examined was so close that you couldn't even tell a difference. And notice here, if I keep zooming in here, see how close it is? There is how close. I keep zooming in. There is how close I am. But notice, I mean, I'm not at 2a. That's my original blue point, and that was the point negative 2.0001, negative 8.000149. Okay. Now let's zoom way back out. Getting the global picture here. I'll even turn that last secant line off, and here is going to be the equation of my tangent line, because we have just, I think, correctly guessed that the slope of the tangent line is going to be 2. So if the slope of the tangent line is 2, well, then we can easily find the equation of the line, because that's y, just like we've been doing, y plus 8 equals m, which we're going to say is 2, times x plus 2. And there we have it. Green. There's my tangent line. I can actually turn all these points off, clean everything up a little bit, and there is my tangent line. Okay, so what do I have here? I have my original function, I have my point in question, and I have my tangent line. Now, what did we do there? What was that process? We originally had the point 3,9, and we picked x values that approached negative 2 from the left. Now, you could have done this process starting from the right if you wanted to, but the way the question was set, we approached from the left. Okay, so we started at negative 3, and then we found the corresponding y value. Then we moving to the right from the left, and we picked the point negative 2.5, negative 8.75. Then we went even further right on the x-axis to negative 2.25. Then negative 2.125. Then we got really close. It's where it's so close you can't even tell from here. And then we got even more super close. Again, we're zoomed out here, so you can't even tell. But we're moving closer and closer to the point of tangency from the left. And in the process, we're getting better and better approximations for the slope of the tangent line. And you can see, just to reiterate, our first secant line had a slope of 1. The second secant line had a slope of 1.5. The third secant line had a slope of 1.75. The fourth secant line had a slope of 1.878. so forth and so on. 1.999, then 1.49999. And if you keep getting closer and closer on the left, from the left, moving towards -2, towards the right, you get closer and closer to +2. And that, now I have answered question 7 and a lot more that question 7 didn't even ask, but I hope this helps you understand what's going on, what we're doing. We're using algebra to approximate a calculation that calculus is going to make trivial. We're going to learn how to find this slope of the tangent line in, for this particular example, for this function right here, you'll be able to find this answer, which was 2, for the slope of the tangent line. You'll be able to find that in 30 seconds. I don't know, I'm not sure how long I've spent here. I spent maybe 30 minutes talking about this, maybe less. We'll be able to find this in a few weeks. Probably in a few weeks, 3-4 weeks, maybe less. Less than that, 3 weeks or so. Chapter 2, we'll be able to find the slope of the tangent line at this point in 30 seconds, a minute. It'll be so easy. That's what calculus does for us. Without calculus, it takes a little while. Now I, talked a lot, probably more than you wanted to hear, but I wanted to make a point here, and that point is that as we use algebra takes a little while to do. Calculus is going to make this process super, super, super easy. So I hope this helps you. If you have any more questions, feel free to ask. I also posted an explanation on the Ask Your Instructor message board, and you can always email me and I'll answer questions during class. You guys have a good weekend. Talk to you soon.